Hi guys, hope you are fine and doing well. So today we will be discussing this problem from the Codeforces round 781, which is tree infection. So the problem tries to say that we are given a rooted tree with n vertices. The vertex 1 is the root, and initially all the vertices are healthy. And each second we are given like two operations. One of the operation is spreading, and the other operation is injection. So the spreading operation is defined as like for each vertex V, if at least one child of V is infected, then we can spread the disease by infecting at most or at max one other child of V, and it can be of our choice. And the injection operation is defined as that we can choose any healthy vertex and infect it. So after the operations, we will continue the process till all the vertices of the tree are infected. Then we need to return the minimal number of seconds needed to infect the whole tree. So this problem is actually a bit difficult to visualize once we read it, but it really makes sense when we pick up pen and paper and try to draw the tree diagram and then implement these two operations. So firstly, I have created a tree and I will be performing the operations that are mentioned of spreading and injection so that we get bit comfortable uh, and we can visualize better like how the things are happening. So I will be denoting first operation by slash and second operation by zigzag line. So firstly, uh, the values in the nodes that are mentioned are nothing but the number of children of that node. So like here the value is 3, so 3 children are present. So that is what it means. So let's start. Since we know that initially all the vertices of the tree are in healthy form, so the first operation that we will perform is of the injection type, which is second operation. So here I will just run the timer and nodes affected. So here I'll keep the count of nodes affected. So when the timer is 1, basically the first second, so the total number of nodes that will be affected is, firstly I will check for the first operation, like is the first operation possible. So there is such no such parent where there is a single child, at least a single child that is infected. So this operation is not possible in the first second, so I will do the second operation. I will simply inject this vertex, and the total number of nodes that will be affected in the first second are 1. Now for the next second, which is 2, I will check for the first operation. Like, is there any parent where there is at least one child which is infected? So I found out this parent that it has at least one child infected, regardless of like which operation it was if, infected from. So yes, now I can perform the first operation. So I'll simply cut it with slash because this denotes first operation. And now I will check for any other parent there is if there is any other parent which has at least one child infected. So it is obviously not there. So then I will move on to the next operation that I will do a second operation. Second operation I will do on here. I'll again inject this vertex. So in the second, basically 2th second, with how many nodes were affected were? They were 2. So in the next second, which is third, how many nodes that will be affected is I will look for the first operation that is applicable on any vertex. So here there is one parent which has at least one child infected, and here is also another parent which has at least one child infected. So these both parents are like eligible for the first operation. So I will just perform the first operation on these two vertices, and then I don't find any other vertex which is applicable for first operation. So I will just simply perform second operation. So I'll be performing second operation here. So the reason why like I am every time performing second operation on different circles is like because logically if we think is that for every timer that we are that is moving, we want maximum number of nodes that should be affected. So if we want that thing to be right, then we every time we have to like perform second operation on different circles, and that too in decreasing form. Like firstly we did on where the it had four children, then we are doing it on where is three children, and then again we will be doing which has three children, and then two, two, one, and one. Because as the timer moves, first operation is just like a leverage to us. So this will help us in like reducing the number of vertices that are healthy significantly. So that is the reason why every time we are just choosing another vertex from any other circle. So in the third second that the things will play out is, so we did this first, we cut out this first vertex, then second, and then third. So total number of vertices that are affected is three. So for the fourth second, what what is the scenario? So firstly, for the first operation, which parents are eligible? Number one, number two, and number three. So we will be performing first operation on these three. So after we have performed first operation on these three, then we will move on to performing the second operation. Since we are done with performing second operation on this four, which has four children, then we are done with three children, and now one three is left, which is this one. So we will be performing second operation here. So the total number of nodes that are affected are three of the first operation and one of this, so four. So for the fifth second, what will be the scenario? We will check like where all first operation is applicable. We will check for the parents which have at least one child which is infected. So this is also a valid parent, but it is already infected. So we don't need to do anything in this case. And this is also the case, but here also all children are infected. So we cannot perform the first operation. But here we can perform the first operation since it has two children infected and still there is one left. So we will perform first operation here. And again, this is also a valid parent which has at least one child infected. So the basically the second operation that will perform is of the first type is on this one. And now we observe that there are no other vertices where like they have at least one child which is infected. So then we will move on to the second operation. So then the second operation we will do is on this second one. So either we can do it here or we can do it here. So let's do it here. So the total number of nodes that were affected were, we did two of first type and then three. And for the sixth second, what will be the scenario? For the sixth second also, we will check which all parents are applicable for the first operation. So this is the parent applicable for first operation because this is the child which is infected and still there is one left. So I'll perform this operation here. And again, this is also a valid parent where we can perform the first operation. So I'll perform this first operation here too. And then I'll look, since there are no other parents where I can perform the first operation, then I will perform the second operation. Now I will be doing on which has two children, which is basically, let me clear this out. Yes. So the total number of nodes that were affected were again three. Now for the seventh second, we will look for the first operation. So this is the parent which is eligible. right? And no other parent is eligible. So we will simply just do first operation on this one, and then we will move on to the second operation. So the second operation that we will do is on this, because there is no other vertex left and we have to do it where there are like just one child, right? So yes, that is done, and the total number of nodes that were affected were 2. And now on the eighth operation, only one node is left, which is the root itself. So we will perform just since there is not a applicable for first operation, so we will just perform second operation, right? So these are like this is how we will be performing these two operations on any given tree. So the other way of looking at this is like, just let me clear this. Yes. So we can look it in this way too. Since we performed all the operations and came out with the conclusion that 8 seconds are required to make like all the nodes of the tree infected. So the other way we can portray it is like, firstly for the first second, if we just inject one operation, we just don't care about like which operation we are performing. So the basic idea is in the first operation that the total number of nodes which are healthy will be left out to 3. So as we see that only one node is affected. For the second, what we will observe is this operation, this will become to 2. Why? Because first operation will play out here, and for the next, here we will perform the second operation, which will leave the total number of healthy vertices to be 2. So here 2 nodes were affected, as we can see here. So for the third second, what will happen is this 2 will become 1, because first operation will play out here, and similarly first operation will play out here too. So it will become to 1, and then will come the second type of operation. Then it will make it to 2. So the total number of nodes that were affected are 3, as you can clearly see that. So basically, I have written these numbers like 4, 3, 3, 3, 2, 2, and double 1 as they are in descending form, and they are just the total number of children of particular node. So that is what I have written here. And for the fourth second, what will happen is for the fourth second, this will become to 0. This will become to 0 because of the first operation, and this will also become to 1 because of first operation. And then we cannot perform first operation on any of the other. Then we will perform second operation here, which is which will make it to 2. So the total number of nodes that were affected are 4, as we can rightly confirm from here. And now for the next operation, which is for the fifth second. On the fifth second, this will become to 0 because first operation will play out. This will become to 1, and this will become to 1 because of the second operation. So total number of nodes that are affected are 3. And for the sixth one, what will be the case? This will become to 0. This will also become to 0. This will become to 1. So the total number of nodes that are affected are 3. And for the next seventh second, this will become to 0 because of the first operation that will be performing here. And this operation will become to, this will become to 0 because of the second operation. The total number of nodes that were affected are 2. So for the last, we will just perform second operation on this root node, right? So this is the other way of looking at it. And here also we hereby confirm that the total number of seconds that we took are just 8 seconds, right? So now let's check if our hypothesis is correct for any of the given test cases. So I will be taking this first test case. So which is something like, so the total number of children of this is 3, 2, 0, 1, and similarly 0, 0, and 0. So we'll be just taking 3, 2, 1, and another 1. Why? Because this is for this particular root node. So now let's confirm if our hypothesis is correct or not. Yes, for the first second, what we will do is it will become to 2, right? So for this first second, the total number of nodes that are affected are 1. For the second, what will happen is this will become to 1 and this will become to 1. Total number of nodes affected are 2. Now for the third second, what will happen is this will become to 0, this will become to 0, and this will also become to 0. The total number of nodes affected are 3. And for the fourth second, just this node will become to 0, and in total we took 4 seconds. So now let's confirm if our answer is correct. Yes, here the answer is 4 only. Actually, there is another left out thing in this algorithm that, for example, when we are given a case, generally whenever we were iterating, so when we reach till the last index, so generally all of the before uh, vertices became to 0, and that means they all were they all became infected. But let's suppose this case when we are provided with this 4, 4, and 1. So basically, this means that 4 and 4. So this is what 4, 4 means, because here the children will be 4 and here also the children will be 4, and that's 1 for this uh, root node itself. So what will play out here is 4, 4, 1. For the first second, what will happen is this will become to 3, right? So for the second, what will happen is this will become to 2 and this will become to 3. So for the second, what will happen is 2 nodes are affected, and for the third second, what will happen is this will become to 1, this will become to 2, and this will become to 0. So the total number of nodes that are affected is 0. Now when we reach till the last index, we are still left with like those numbers, sorry, those vertices which are still healthy. So for the fourth second, what will happen is this is really important. Firstly, first operation will play out, so this will cut to 0, and here also the first operation will play out, so it will also make it 1. But now we are left with another operation of the second type. So what will happen is, so we will perform second operation on this one, so it will become to 0. So here again the total number of nodes that are affected is 2 only, but the total number of uh, reductions that we have made from healthy to unhealthy are 3. So generally they seem to be equal, but in this case they are not equal. So now let's have a look at the code, but before that just let me clear this out so that it will be easy for you to understand. Yes, yes. So firstly I took the input for the test case. What are the number of test cases? And then I took the input for n and array A which represents like the particular value at index is the parent of that index. So let me take this example like 111 224. triple one and double two four. So yes, this value is the parent of 1. So it is basically of 2, sorry, because there are n minus 1 indices available. So similarly, this index is parent of 3, right? So this is the way what these values mean. So then I have created a hash map, and the reason behind of creating this hash map is that I want like an array of the form like this 4 3 3 3 2. So which contains the total number of children it has. Like this 3 represents this node has 3 children. So in order to do that, I have made hash map where I calculate values for like 1 comes 3 times, so 2 comes 2 times, and 4 comes 1 time. So this shows that like 1 has 3 children, 2 has 2 children, and 4 has 1 children. So this is what it means. So we have got this values, and then I have added 1. So this one is represents basically the root node. So this is what we have got, and I have stored this in array list. So from the array list, now I sorted this array list in descending order. So it will look something like this: 3 2 1 1 for this test case. And then I have just copied the values from the that array list to array A. Array A is reinitialized to the size of this list, which is just 4. 4 is the size of the list. So this is what array A will looks after it has been like copied from list. And then I have performed some operation, like I have initialized n to the length of the list, which is again 4, and count. I have initialized the count to n. Since I have initialized count to n because I am sure that the minimum number of operations that it will take to make all the elements 0 is like the total count of the array, which is basically 4. So that is the reason I took that. And now I have applied a for loop which states that since n is 4, so definitely after 4 operations this will become to if we keep subtracting and perform the first type of operation, it will become to 0, and this will also become to 0. So this will also become to 0. So after 4 operations, these all will become to 0. So it is just that I have done that a of I is basically maximum of a of I minus n minus I, because for the first time, for the first iteration, this will lose one extra amount of vertex, and this will lose one less, and similarly this will lose another one less vertex. So that is the reason I did that. And after that, if I am left with I have applied while loop, which is basically true, and then herein I am checking if all the elements of the array are 0. In case they are 0, then I will break out of this loop and just return my count integer n. But in case that elements are still left after like n operations also, like we had the case of 4 4 and 1. For this, like for the first time it is becomes 3, and then it becomes 2, and this becomes 3, and for the next operation it becomes 1 and 2, and it becomes 0. So here we have completed like 3 operations, but still we are left with 1 2 and 0. So it is uh, 1 second. Yes. So still like all the elements are not 0. So now we have a leverage that we can use this second operation another time. So what I will do is I will just iterate over this array and reduce all the numbers. First I have like sorted this array here, So after sorting, this array will look something like 0, 1, and 2. So after that, I have just subtracted any basically vertex of, at that iteration if it is not 0. So it will become to 0 and this will become to 1. So this is the basically first type of operation that I have done. So as you can see here, I have done this first type of operation, and after this for loop, if the last index is still greater than 1, so I have subtracted another 1 from it. Why? Because this represents the second operation. So this has to be done only single time. So that is the reason I did that. And I'll simply count plus plus because this is the timer. Because for the next second, which is after 3 operations, this was the fourth second. For the fourth second, the values will be like 0, uh, yes, 0, 1, and 2. So this is what it means. So after that, it will also become to 0. So then I will output simply my count variable. So hope you understood the problem. And if you appreciate my work, you can give a thumbs up to this video and consider subscribing to my channel so that you don't miss any of the upcoming updates. So let's meet in the next video. Till then, bye bye.